Welcome to
Nay.
Do it.
Channel Everyone. This is episode 2026-0413. Okay, so today we are diving into a paper that asks a really fundamental question. Jiang, the title is, do we really need to approach the entire Pareto front in many objective Bayesian optimization? My first thought was, Pareto front, many objective, this sounds like a mouthful, but the core question feels almost philosophical for optimization. Do we need to map the whole mountain, or just find the best path for our specific hike?
That's a great analogy, Isabel, and it cuts right to the heart of a practical bottleneck. In multi-objective optimization, we're balancing competing goals, like designing a phone. You want long battery life, a great camera, a slim design, and a low cost. Those are four objectives. The Pareto front is the set of all the best possible compromises, where you can't improve one thing without making another worse.
Right, and the classic goal of algorithms has been to find a diverse set of solutions along that entire front. To give the decision maker, the product manager in your example, a whole menu of optimal trade-offs to choose from.
But the paper says, hang on, what if we have a many-objective problem, more than 3 of these competing goals? And what if, like in Bayesian optimization, we can only afford to test a few hundred possible designs? Trying to map that entire front becomes, what's the word?
Exponentially challenging. The space you need to explore blows up. It's like trying to map every single viable path on that entire mountain with only a dozen drones. You'll get a sparse, probably poor map, and in the end, as the paper notes, the decision maker only picks one final design, one phone, one path.
So they're proposing a shift in mindset. Instead of spending our precious, limited evaluations trying to sketch the whole menu, why not focus all that effort on finding the single best dish for the customer's taste, or in technical terms, finding a single high-quality solution along a preferred trade-off direction?
I love that it's so pragmatic. It accepts a real-world constraint, limited budget, and asks how we can be most useful within it. So their framework is called SPMO, Single Point-Based Multi-Objective Search, and the key is this acquisition function called ESPI, Expected Single Point Improvement. Can you break down what that's actually doing in a simpler way?
Of course, think of it as a very focused scout. Instead of sending scouts out in all directions to map the terrain, this scout is given a specific direction to explore, a direction that represents a good balance between our objectives. Maybe the product manager says, I value camera quality twice as much as battery life. The ESPI scout then only looks for improvements along that specific line of compromise. It asks, if I test asterisk this new design, what is the expected improvement? Specifically for asterisk my asterisk preferred trade-off. It ignores everything else.
And they show this isn't just a heuristic. They provide convergence guarantees, meaning under certain conditions, the method is mathematically proven to zero in on the best solution for that direction. They also make it practical by showing how to optimize it efficiently with gradient-based methods.
So how did it actually perform? Did this focused approach beat the traditional map the whole front methods?
Empirically, yes. Across a range of benchmarks and real-world problems, their SPMO framework using ESPI often found a better single solution for a given preference direction, and did it faster than state-of-the-art methods that were trying to approximate the entire Pareto front. It's a compelling result for resource-constrained scenarios.
It really highlights a key principle in engineering and science. Sometimes, the optimal approach isn't the most general one, but the one most suited to the actual constraints of the problem. If you only need one answer and you have limited time to find it, designing your search around that reality is just smart.
That's a fantastic takeaway. It's about aligning the algorithm's goal with the end user's real need, not just a technical improvement, but a philosophical shift in how we frame the problem. Thank you both so much for climbing this conceptual mountain with me today.
Thank you, Isabel.
Thanks.
And thank you for watching. We'll see you next time on I Do It channel.